All right, so we are going to talk today about, we're going to start today with piecewise function. So here is what I need for you to do. Let's get out our books and look on page 114. And while you're doing that, I want to make sure we talked about one more thing. The quiz we just took, you had to move things around. So we know that if we take one of our functions and we add or subtract to it, we know what adding or subtracting a number does. Adding or subtracting a number moves the picture. Whether it's up and down, left or right, that's what that does. What does it do when we put a negative? And there's two ways to do that. We can put the negative out on the function itself, or we can put the negative on the E. Have we talked about that? Okay, good. Then this is what we'll do, and then we'll go to page 114 of my book. Does anybody have any idea what putting negatives in these various places does? You know, because you spent a lot of time last year graphing upside down parabolas, right? That negative turns the thing upside down. So when you put a negative on the function itself, out in front, on the function itself, it's going to turn it upside down. So you all know, or should know, what e to the x looks like. That's what it looks like, right? And that's the 0.01. You know what that looks like. So putting a negative is going to reflect it or flip it across the x-axis. So this picture would look like this, and this would be the 0.0, -1. Does that make sense to you? Now, negative out in front flips you across the x-axis, or I like to think of it as turns you upside down. What do you think a negative actually on the x does? It flips across the y-axis, and if you think about it, that makes perfectly good sense. If you change the sign on your x-coordinate, in other words, if you go from a +2 to a -2, doesn't that flip you across the y-axis? It goes to the other side of the y-axis. So again, here's my original. I always start with my original. Here it is. If I flip that across the y-axis, aren't I going to get this? So that would be a picture, and that's still the 0.01. That would be a picture of this. Everybody okay with that? So let's try one more. Let's do our cubing function. All right, so let's talk about this and this. All right, so what does a negative there do? I'm going to dash in there's my cubing function. What does a negative on the x do? Flips you across the y-axis. So I'm going to take this, I'm going to flip it across the y-axis, and I would get this. Would everyone agree with that? All right. What does this one do? I'm going to dash in my original. What does that one do? Turns you upside down. So this guy would end up looking like that, and this guy would end up looking like this. Oh my gosh, what happened? They're the same thing. Do you have any idea why that is? Because this is an odd function, and odd functions have symmetry about the origin, which is the same as having symmetry across both the x and the y axis. So there we go, same thing, it's an odd function. And if you look at the equations, doesn't this equal this? I mean, if you simplified it, wouldn't it be equal? Sure. All right, so now we know what reflections do. So in addition to memorizing your BFFs, which you hopefully have a good handle on, you have to remember the difference between adding or subtracting like this and adding and subtracting like that. And then you have to remember the difference between putting a negative there and putting a negative here. Lots to remember. Okay, now, on page 114, let's look at problem number 46. This is what we call a piecewise function. And it's pretty obvious why that is. The function is written in pieces. And when we graph it, we're going to graph it in pieces. Okay, now there's always more than one way to do it. But years and years and years of doing this, there seems to be one way that kids manage it better. So that's how we're going to at least start it today. We're going to graph this. It's two pieces. This one is just two pieces. They could be 3 or 4 or 5. This is two pieces. And we're just going to forget everything in the problem except this right here. This says basically y equals x cubed. Forget everything else for a minute and start with that. Y equals x cubed. Okay, so that looks like this. I know that because it's one of my BFFs. Now we're using pencil because we're going to do some erasing. Why are we going to erase? Well, this says y equals x cubed, but not always. It only equals x cubed if x is less than or equal to 0. So where on the graph is x less than or equal to 0? Equal to 0 here and less than here. So I don't want this part of it. That's part of x cubed, but I'm only allowed to look at this part of x cubed. So I'm just going to erase the piece that I don't want. Now, guess what we're going to do? We're going to go to the next line, and we're going to graph that. So here we go. Y equals e to the x. Looks like that. And that would be great if that's all there were. But we've got this now. So what part of e to the x do we want? Just the part that has x bigger than 0? So I'm going to put an open dot right here. Why is that dot open? Because it's not or equal to, right? And I'm going to erase all of this. And that is a picture of my piecewise function. Very strange looking thing. What's the domain of this piecewise function? All real numbers. If you said all real numbers, you are so on it this morning. Right there's your domain. Your domain is your x's. Everything bigger than or equal to 0 or less than 0. Isn't that everything? Now look at the picture carefully. What's your range? Be careful. I know you see this going down, and I know you see this going up. So you're tempted to say all real numbers for the range, but what's wrong with that? There's that little gap in the middle, so our range is going to have to be in two pieces, right? So what's our range? Negative infinity to 0 bracket, because that 0 is colored in, or 1 parentheses to infinity, because that 1 is not colored in. That's the range of this function. Let's try another one of those. Let's try number 48. two pieces. There's a lot. That looks very confusing. So let's break it down. Let's only look at this right here. What does that look like? Just this. What does that look like? That's which function is that? Reciprocal. And it looks like this. Everybody okay with that? Now, what part of that do I want? When I'm doing these things in pieces, I never want the whole thing. I only want a piece of it. Which piece do I want? Less than 0, which would be this piece over here. So I don't need this. And if you were thinking ahead, maybe you didn't even draw that piece on there. It's easy for me to erase. I know it's a little harder for you. All right. So now I'm going to look at this one. And I know what that looks like. That's this. Should that be a solid dot colored in like that?
Yeah.
Yeah. And in fact, I don't need to erase any of this because all I have with that function is greater than 0. Would you agree with me? So that's my picture. That is it. Okay, domain.
All real numbers.
All real numbers. It's right here. Domain is X. They're telling you your domain. How about range? Look at your picture. Can you figure it out? What's your range?
From negative infinity to 0.
What do you think? All real numbers. Your range is also all real numbers because even though there's an asymptote here that would exclude 0, it's included right there. So everything is included. So your range for that one, even though it's broken, the function's discontinuous, is all real numbers. Okay, we're going to do one more. This one's got 3 pieces to it. So let's do number 51 on page 114. And then you'll be ready to do this by yourself. So let's see, 51 says. Okay. Now, do not be scared. Do this. It looks scary, but we can do it. One piece at a time. What shape is that? Paint in white. What shape is that right there? This is y, so you've got y equals negative 3 minus x. That's a line. And what's this negative 3? Anybody? That's the y-intercept. And what's this negative 1 right here? Slope. So that means I'm going to go up 1, left 1. Not really good drawing lines, but there we go. There's the whole line. The line y equals negative 3 minus x. Now, what part of that line do I want? Remember, this is a piecewise function, so I just want pieces of everything. What piece do I want?
That's less than 0.
Where x is less than or equal to 0, so that would be the left side of the picture. I'm going to leave that solid dot colored right there, but I'm going to erase all of this. Does that okay with everybody? Now, next row says literally y equals 1. What does that look like? That is not one of our BFFs. What does y equals 1 look like, Katie? It's just a horizontal line. So that would be this right here. Here it is. There's the line where y equals 1. Now, what part of that line do I want? Not very much of it, right? I only want the part between where x is 0 and x is 1. And neither one is included. So I'm going to put an open dot there and an open dot there, and that's the part that I want right there. So I don't want all of this or all of this. How is that? Is that okay with everyone? What's that? The bottom one now, the third piece. What's that? That's your parabola. I'm going to sketch in my parabola. There it is. And what part of that do I want? Everything from 1 to the right. So I'm going to start right here at this point and keep all of that and get rid of all of this. Now, one thing I haven't talked about is that these are all functions. Does this, as strange as it looks, does this pass the vertical line test? Yes. Now, you might be a little confused here, but remember, that point's not included. So that passes the vertical line test. That is your function. Domain? All real numbers. It's all included up there. The x's, that's your domain. It's all there. How about range? Everything above -3, including -3?
Yeah.
That would be your range. Picture starts here and goes up. All right. One more question on this page. It's not a piecewise function. I just thought it was interesting. 69A. 69A. 7 of the 12 basic functions have the property that f of 0 equals 0. Now, what does that mean? When we say f of 0 equals 0, what does that mean about your pictures? That is a point. Remember, you got y equals f of x. So there's your f of x, and there's your y. So this is the point 0, 0. So 7 of the 12 functions contain the point 0, 0. If we say f of 3 equals 4, what does that mean? That means that what point is on the graph? 3, 4. That notation, function notation, just describes an ordered pair. So this problem says 7 of your functions contain the point 0, 0. Can you think of the 7 that go through the origin, basically? What are the 7 that go through the origin?
Identity.
The identity, for sure. I'm going to write the equations. The identity, for sure. X squared contains the origin. X cubed contains the origin. Square root function contains the origin.
Absolute value.
Absolute value. Sine function goes through the origin.
Exponential.
What?
Exponential.
No, the exponential does not. The exponential, remember, has an asymptote at 0. Oh, it's the hideous one, the awful one. The greatest integer function, remember, does contain the origin. So there they are. Very, very good. Good. Okay. All right. Now we're going to spend a little bit of time talking about function operations. What do I mean by that? Well, let's make up a couple of functions. Marty, give me a function, any function. You don't have to do one of the special ones. You can just make one up.
X to the third plus 2.
Plus
2.
2. All right, that's a good one. All right. And then, let's see. Margaret, give me another function. X squared plus 4. All right. Now, let's suppose that for some reason we wanted to add these two functions together. What do you think that answer would be? And let's not overthink this. It's exactly what you would think it would be.
Parentheses, x to the third plus 2, parentheses.
And you know what? Let's just add them. Let's bag the parentheses. For addition, it's not necessary. So what would I have? X cubed plus x squared plus 6. That's it. That's all there is to it. It's that easy. If we want to subtract them, then I would suggest maybe using parentheses only as a reminder of what? Distributing the negative. Now, some of you are going to do that in your head, and it's perfectly okay, as long as you do it. Okay, so did I do it? Does that look okay?
Yeah.
Easy. What if you wanted to multiply? And I want to emphasize here that when we do multiplication, we have to use the multiplication symbol. I know with regular numbers, sometimes we can just go like this, and that means multiplication. Not with functions, that means something different. So you physically have to put in the times sign if you want to multiply them. So that's what we're going to do. We're going to multiply them. So that will be what? How do you think we'll accomplish this? We will FOIL. So our answer will be x to the 5th plus 4x cubed and 2x squared and 8. Nothing adds up, so that's it. And then division, same thing. That would be x cubed plus 2 over x squared plus 4. And then we would do any canceling or simplifying. This one doesn't, so we're done. But if sometimes you can, and you would. Okay, is everybody all right with that? That's pretty easy. So that's the basic for regular arithmetic operations. With functions, oh, and you guys picked kind of hard ones. With functions, we have another operation there that we can do, and it's called composition. And just like in English, composition is when you put a bunch of words and sentences together. A mathematical or function composition is when you put two or more functions together. The notation we use, and there are a couple of different ways you can do it. One way is this. Another way is this, with this little open circle. Have you seen that before? That little tiny open circle there? And both of these, the notation is exactly the same. Both of them say G of f of x. Now y'all know about functions. You know exactly what to do. If I say find g of 3, you know exactly what to do. What do you do if we're finding g of 3? You put, every time you see an x, you put in whatever you said to put in here. So if I say g of 3, every time I see an x, I'm going to put in a 3. Right? Now, that's how you do functions. They're input-output machines. This is your input. What are you inputting? And it doesn't matter what that is. So in this case, it says find g of f of x. That means you're going to take your g function and you're going to input f of x. So we're going to find g of x cubed plus 2, which means exactly what it meant when we found g of 3. Take out the x and put in whatever. So we're going to take out the x and put in x cubed plus 2. So g of x cubed plus 2 is x cubed plus 2 squared plus 4. So that's a FOIL. And so x cubed plus 4x cubed, or x is 6 plus 4x cubed plus 8 is our final answer. Now you guys picked some tough functions, so I'm gonna, if you don't mind, I'm gonna change our functions here so I can do a couple more examples without them being quite so complicated. So let's look at a couple easier functions. Let's say h of x is 2x minus 1 and c of x is 5x. All right, let's see if we can build the composition h of c of x. You did this last year, right? It should look somewhat familiar. What's c of x?
5x.
5x. So what we're really doing is finding h of 5x. C of x is 5x, so I'm finding h of 5x. Now what does that mean? H of anything means take out the x and plug in that. So it's going to be 2 times 5x minus 1, which is 10x minus 1. And we're done. That's all there is to it. What if we did it in the other order? So instead of saying h of c of x, what if we said c of h of x? Do you think it's the same thing? Do you think I'll get the same answer? Yes? Well, let's see. What's h of x? 2x minus 1. So I'm going to put 2x minus 1 into c. So c of 2x minus 1 would be 5 times 2x minus 1, which is 10x minus 1. Uh-oh, did they match? No. Composition is not commutative. In other words, order matters, so you have to pay attention. And remember that you always plug the second one into the first one. So the second function goes into the first one. Let's try one more example. Let's see say b of x is x squared plus 1, and q of x is 3x plus 2. On your paper, would you find b of q of x? See if you can find b of q of x. Did you start by saying, okay, q of x is 3x plus 2? So I'm finding b of 3x plus 2, which means 3x plus 2 squared plus 1, because in the b function, whatever you plug in, whatever it is, gets squared and then added 1. So did you end up with 9x squared plus 12x plus 5? So we're doing period, yeah. Is that what you ended up with? All right, well, we'll pick up here, I see tomorrow, right? So we'll pick up here tomorrow, and we'll get your quizzes back. You should now be able to have all of 1.1, 1.2, 1.3 done, and most of 1.4.